So we are going to revisit linear approximations. So something that we've already done, but we will do both levels of this, and you'll see it on the Delta Math. So specifically, we're going to be working with that point slope form. And for Delta Math purposes, we're going to move that y1 over to the other side. But we'll start with the top equation. And so our objective here is twofold. One is we want to get that equation. So we know we're going to need a point. So that's where we're going to use that given f of x, because we're going to see when x is some value, what's its pairing, what's its y, what's its corresponding y. And then we're going to need to find f prime of x, because the next question is, if I have a point, well, the next thing I need is my slope. So let's just look at a couple of examples. So here we go. Here is the first of our questions. We are given that f is differentiable, and we know these two things about f. F of -3 is 8, and f prime of -3 is 9. And we want to use that information to make an approximation for f of -3.2. And we're going to use the tangent line to make that prediction at x equals -3. Here's all that information that they gave us. And you'll notice that with that part, they gave us the point. We know point. With this part, we're given the slope. And again, this is the point value at x equals -3 and the slope at x equals -3. Let's put it in point slope form. And our point slope form looks like this. Great. So now we're going to use that to make an approximation for f of -3.2. That just means I'm going to plug in -3.2 into this equation to see what its corresponding y value is going to be. So we see when we plug in -3.2 for x, we get this, which cleans up to give us this, and we math it out and we get 6.2. So that tells us that an approximation for f of -3.2 is 6.2. So level 2 of this gives us the same information, or asks us for the same information, but then it also introduces concavity. And the concavity allows us to determine whether or not the prediction that we made was either an over or an under approximation. You'll remember this. So the two scenarios that we have is that our graph is either going to be concave up or concave down. We identify that if my graph is concave down and I'm using a tangent line to approximate a value near that x, it's always going to be slightly under the actual y value. So that predicted is going to be less than the actual. So that's where we would say if our graph is concave up, our prediction is an under approximation. Conversely, if we're working with the graph that's concave down, you'll see that your tangent line is now above the graph, which then tells us that any approximation that we make is going to be slightly larger than the actual value. So when our graph is concave down, we know that this prediction is going to be an over. That's an under, this is an over. Why on earth did I put the plus or minus there? It's because this is when we're going to need to look at the second derivative to determine what the concavity of that graph will look like. So let's do an example. So you'll notice in this example, we're given that f of x is -3x to the 1/3, and we're asked to make an approximation for f of 8.1 using the tangent line to the graph at x equals 8. So here we're going to look for a few things. The tangent line, so we're going to have to give that. The approximation, we're going to need to give that. And then this business right here, when our, try to get over there. So that's just going to tell us if it's at 8, well, we're working with a positive x value. That's weird. We don't see that typically. And then we're going to need to determine whether or not that prediction that we came up with is an over or an under approximation. So I'm going to write this all down so we can work through this information. Here we go. We're going to need to find the tangent line. So first I need the point, then I need the slope, and then to determine whether or not this is going to be an over and under approximation, we're going to need the second derivative. So let's just start with the point. So we are using the x value, x equals 8, for all this information. So let's figure out what the y value is at 8. Well, that gives us -3 times 8 to the 1/3. 8 to the 1/3 is 2. That's the cube root of 8. So we've got the ordered pair. We know that the point 8, -6 is on that graph. So that's my point. And now we're on to the slope. So we want to find f prime of x. So we're going to look at that equation and we're going to derive it. Yeah, so that's going to give us -3 times 1/3. So that's -1. I don't know why I put the 1 there. So that's -1. And now x is raised to the 1/3 minus 1. So that's -2/3. Did I do that right? Yeah, I did that right. And so now we want to find f prime of 8. So that's -8 to the -2/3. And so that's going to equal well, 8 is 2 cubed. So then I can clean that up. That's -2 to the -2, which is the same as -1/2 squared. That gives us -1/4. So that tells us that our slope is -1/4. So I've got all the information I need to write my equation. Here's our tangent line, and we are asked to use that to make the prediction for f of 8.1. So our next step here is we're going to plug in 8.1 for our x. So that gives us this, which simplifies to that. I'm guessing that we don't have a calculator for this, so I'm just going to keep manipulating this. So then that 0.1 is 1/10. So that's y plus, let's move this up. Wow. Y plus 6 equals -1/40. So y equals -6 minus 1/40. So that's -6 and 1/40th. I don't know if they do mixed fractions in Delta Math. So let's change that to an improper fraction. So 40 times, that's -240 plus 1. Don't you hate it when the answers look like this and you think you're wrong? Okay. That looks to be our approximation for f of 8.1. We're not done. Then they asked us if this is an over or an under approximation. So that's when we need to bring in f double prime. So I've boxed what f prime of x is, and I'm going to clean this up so I have a little more space. So now we need to find f double prime. So I'm going to take that f prime of x and derive it. So now I'm on to this. That's +2/3 x to the -2/3 minus 1, -5/3. Yikes. So then our question is, what would the sign of f double prime of 8 be? Well, I don't know what this is, but what I do know is that is a positive number times a positive number, so I know that that is positive. So let's get back to our problem in Delta Math. So now we just type all that stuff in. So, oh shoot, I wrote it down. My tangent line was, so I'm going to move that 6 over to the other side. So that was -6 minus 1/4 times x minus 8. That's right. Our approximation was -241/40, I think. 41/40. So when we've got a positive x value, we took f double prime and we saw that that was positive, meaning the graph of f is concave up. And if my graph is concave up, what do I know about my tangent line approximation? It's an under approximation. We cross our fingers. Hallelujah. So that is, oh, well, again, they gave us decimals. Maybe you can use a calculator. I don't think you can use calculators for these approximation problems. So I would do these by hand. All right.